Hello, in these videos, we are going to look at the idea of power series. So section 11.2 is all about what is a power series. A power series is a special series that is of the form when we have the sum k equals 0 to infinity of c sub k x minus a to the k, where a is a real number, c sub k are real numbers, and x is a variable. So what a power series is it's a series where we've added a variable with an exponent. The c sub k's are called coefficients of the power series, and a is called the center. Now, what this looks like if we write out a few terms is that we would have c sub 0 x minus a to the 0 plus c sub 1 x minus a to the first plus c sub 2 x minus a squared plus c sub 3 x minus a cubed, and so on. X minus a to the 0, we are going to take to just be 1, even when x is a. But otherwise, this form should generally be looking a little familiar to something you have worked with a lot in the past. And looking at an exact example where, let's say, our c sub k's are 2 times k, and x to the k, or a is 0, so we have x to the k. If we wrote out some terms of this, we would have 2x plus 4x squared plus 6x cubed plus 8x to the 4th plus 10x to the 5th, and so on. We start with 2x because when k is 0, everything is 0. But otherwise, what this looks like, if I just said, hey, let's cut off here, looks like a polynomial. If I only took a few terms, it looks like a polynomial. In general, what a power series is it's an infinite polynomial. So we are now working with infinite polynomials. But they are series. So there is an idea of convergence and divergence, but we've added in a variable. So there are going to be values of x for which the series converges. Of if I take an x and I plug it into the power series, it suddenly becomes a normal series. Well, as an example, suppose I said, what if x equaled 1/2? Then the series above here becomes k equals 0 to infinity of 2k times 1/2 to the k. And we could, using all of our tests from chapter 10, determine if this converges or diverges. And then if x equaled 3, we'd have the series k equals 0 to infinity 2k times 3 to the k. We could use all of our skills from chapter 10 to determine if this converges or diverges. These sets of x's that I can plug into the series to determine if the power series converges is known as the interval of convergence. We'll see more about the interval of convergence. The radius of convergence is a distance r from the center of the series to the boundary. So remember, we had this idea where we have a center. The center is really what makes this 0. But in general, that's going to be A. And so from the center out to the boundary of the interval of convergence is known as the radius of convergence. So first, for what values x does the series n equals 0 to infinity of x to the n converge? It's our first example. This series should be reminiscent of a series we've worked with repeatedly. And that series is the series n equals 0 to infinity of r to the n. Or we saw it most often as a r to the n. This is a geometric series which converges when the absolute value of r is less than 1, and it converges to a over 1 minus r. So what values of x does this converge? We're looking at n equals 0 to infinity of x to the n. A is 1, because we don't see any number to be a here. R is x, so this converges when the absolute value of x is less than 1, and it converges to a over 1 minus r. So the interval of convergence is the set of x values where the series converges. Well, those are the values when x is less than 1. The absolute value of x is less than 1. Meaning it's the interval from -1 to 1. The radius of convergence is the distance from the center to the boundary. The center here, if I rewrite this, the center is 0. There's my 0. And so the radius is from 0 out to one of these boundary points, -1 or 1. Whichever one we go to, from 0 to 1 or from 0 to -1, that is a distance of 1. So the radius of convergence is r equals 1. Some other things to note here about this first power series we're looking at is when we talk about what it converges to, that is not just a single number. That is a function. That is the function f of x equals 1 over 1 minus x. So a power series is going to converge to a function. And we'll talk more about the functions it'll converge to. But in general, for right now, this tells us that the series n equals 0 to infinity of x to the n converges to the function 1 over 1 minus x when or for absolute value of x being less than 1. So there is our definition of a power series with our very first example of a power series being a series where we now have a variable put in particular, what they look like is infinite polynomials. Next video, we're going to look at how we can find these radius and intervals of convergence for a power series that's given to us.